Okay, as promised, a video on completing the square and just another breakdown of how we and why we do this. So there's going to be lots of times in this chapter specifically where we have what we call the general form of a quadratic. And the general form of a quadratic is great for when we want to do the quadratic formula because we have A, B, and C like this. Or factoring something like this that we're used to. We call that an even degree trinomial like this. But what the general form is not good at is it's not good at explaining the physical characteristics of a parabola on the graph. And that's what this is good for, right? This is standard form of a quadratic. Now to get here, we have to complete the square. So if we work in reverse, again, this is the end product. This is what we're looking for. If we go in reverse, this is what would happen before that because we have x minus h, that quantity squared. So we would have something that looks like this where it's being multiplied by itself. And before we got to that, we'd have something that looks like this. Now the one thing you want to pay attention to here is that this value of a, it's the same variable as it was in the general form, but it's not next to x squared essentially, right? And that's going to be one of the key components of how we get to this. The other thing is that this value of k, this k is not the same as this c, right? The a is the same as that a, but the c is different. Okay, c and k are different. So without getting too much further down that road, let's see what this process looks like. So again, this is what we call the general form of a quadratic. Okay, we want to turn this into something, some quantity of x, some binomial of x squared. So to do that, the first thing we want to do is we want to look at just these terms. Okay, remember, this is that value of a. I want that outside of this quantity, outside of the parentheses. So the first thing that I do, I'm gonna stop writing this, but all we're doing is rewriting this expression. Okay, and that's key. I'm gonna reference that again here in a second. So I'm not gonna keep writing f of x. I'm just gonna have this expression down here. I want to factor the 2 out of this parentheses. Now you'll notice in this example, 3 does not have a factor of 2. That doesn't matter. I need to get this number away from x squared. So I'm factoring that out. And it's going to look weird. This is going to be a gross problem. We're going to have fractions. It's going to be messy. But I want to emphasize the process and what we're doing here. So I'm essentially, when I factor a 2 away from here, factoring is division. So I'm dividing a 2 out of here, and I'm dividing this by 2. So I have that statement. Now what I'm going to do when I complete the square is I'm going to leave a space here, and I'm going to put the constant over there on the outside. Okay? We're separating this. Now this is, if you remember from the previous slide, that's going to start to be that value of k, right? That's not a finished product, but that's where we have that constant separated on the outside. Now after we get this leading coefficient out of the x terms, what we do next, this is the completing the square part, okay? We look at this number right here. I call that the middle term, right? It was the middle term here after I take the 2 out. I look at this number and I take half of that, okay? Some people call it splitting the middle, okay? We're going to take half of this number, okay? And after we take half of it, we're immediately going to square it. So half of 3 halves. I'm going to write this here and then I'm going to erase it because I'm limited on the space that I have. But we're taking 3 halves and we're taking half of that. And when we take a fraction and divide it by an integer, we multiply this down here. Okay? So half of 3 halves is 3/4. And then we are taking 3/4 and squaring it. That is the process for putting the number up here. So 3/4 squared is 3 squared over 4 squared. And that number, when we take half of this and then we square it and we put it back in, we're adding that value into this quantity. Okay? Now, remember this. Okay? Remember that. We're going to come back to it. I have to erase it now because I'm running out of space, but we will come back to that idea. So once we add the 9/16 into this problem, here's what we have to realize. When I factored the 2 out and I got this and I separated the -4, all of those things were still up here, but this wasn't. This term didn't exist in this expression. I wrote that. So because I wrote this here, I've changed the value of this expression, right? Which is not my intent. My intent is not to change its value, it's just to change the way that it looks, right? So because of that, this 9/16 that I added inside here, I want to undo that on the outside. So I want to add 9/16 and then I want to subtract 9/16, and I want to do that out here. But here's the rub. This plus 9/16 that I added here is being multiplied by this 2. So again, a little bit of margin work. I took 9/16 and I wrote that here, right? But that number is being multiplied by 2. Right? And when I do a little magic here, we get 9/8. Right? If you cancel these, you get an 8 on the bottom. So the quantity that was added here is actually 9/8. And that's why I'm going to subtract 9/8 out here to counteract this. You're like, why don't these numbers match? These numbers don't match because this number is being multiplied by that. It'll seem a lot easier when we're dealing with integers and not fractions, but I wanted to add a little bit of a twist to this problem because it won't be the first one that you've seen probably. But if it is, the process doesn't change. It just depends on if the numbers work out nicely or not. Okay, now getting back to what we have. The whole purpose of splitting this middle and squaring it was because if I went about the process of factoring this, and I won't put you through this torture chamber, but if I went through the process of factoring this, I would have that statement. On the outside over here, you can do this math on your own, but this is 32/8, that 4. Okay, we're dealing with fractions, we might as well jump full in, don't just dip your toe in the water. So we have negative 32/8 minus 9/8 is negative 41/8. Okay, and that, now we have our k value out here. Okay, we'll get to that in a second. So this trinomial factors down into this. Now you're not going to have to show me this every time, but I just wanted to re-emphasize what I showed you earlier on that other slide. Okay, because what happens here, now that I have this binomial, that 2 binomials that are exactly the same, I can write that as just this squared because it's being multiplied by itself, minus 41/8. Now we're in standard form. Okay, we've got our value of h right here, we've got our value of k right here, we've got our value of a right here. Now I mentioned that thing before where I had 3/4 written. When I divided, you'll recall, when I divided 3/2 by 2 and I got 3/4 and then I squared that to get this number, it's not a coincidence that this is the number that's down here. Okay, so when we take half of this middle term, before we square it, that's actually the number that's going to end up in this binomial every single time. Every single time. Okay? So that's why this step right here is not necessary. You could go right from here to here because once you take half of this and square it, you put that number there, you automatically know what's going to go in this binomial. Okay? You just got to do this balancing act out here with that value. Now, not all of our problems are going to look this complicated, okay, but I just wanted to show you a problem that does include fractions, just to re-emphasize the point that I'm taking out this coefficient no matter what, even if it's not a factor of the middle term, okay? We're going to do some more examples, but this is just one to go a little bit deeper into what we're doing.